Alright, and welcome to Slope-Intercept Systems Level 1. Now, in this very first example, it says solve the system of equations below. And as this is our very first video on systems, what is a system? It's when we have two equations or more. So notice we have this line right here, y equals 8. And just to even kind of give you a graphical representation, if you were to think of an xy axis, and you were to think of this line y equals 8, if we went up 1, 2, 3, 4, 5, 6, 7, 8 units on the y-axis, that line would look like that. Now let's say we talked about y equals 3x minus 6. 1, 2, 3, 4, 5, 6. However, notice it has a slope of 3, so our line is going to look something like that. Now when solving a system, we are essentially saying, hey, where is this point where these two things cross? And I'm going to give you 3 different ways to solve this. However, for this very first video series, we're going to focus on these when they're in slope-intercept form. How can you tell if something's in slope-intercept form? Well, the y is essentially by itself. So how are we going to solve this? Well, we take this equation, y equals 3x minus 6, and we understand that y is actually 8 in this other line. So instead of y, we'll simply write 8. And so we have 8 equals 3x minus 6. Now we have a pretty basic Algebra 1 equation to solve. When trying to get x by itself, should we get rid of the 3 or the negative 6? Well, in this case, we know we're going to get rid of the minus 6 by adding 6 to both sides. And ask yourself, what is 8 plus 6? Well, that would be 14. So we're going to say 14 is equal to 3x. Now, how are you going to get the x by itself? Well, let's see, what can we do? Oh, okay, we can actually take both sides and divide by 3. And so we see that for this point right here, if we were to write it as a point, our x value is going to be 14 over 3. Now you might be thinking, wait a second, that's a fraction, and fractions are a little bit scary. However, I wanted to kind of give you a very easy example of a fraction. That's actually a lie. I didn't pick these numbers too clearly, but we lucked out. I'm not even lying. Check this out. We know that y is equal to 3x minus 6. This is one of our equations. And once you find out what x is, we know x is 14 over 3. Well, we are going to plug that 14 over 3 into this x. And check this out. Let's see what happens here. When we do 3 times 14 over 3 minus 6, one thing we should remember from our fraction assignment that we did is that when you have a number in the numerator that is the same as the number in the denominator and you're multiplying, that this is really 3 divided by 3, it reduces to 1 over 1, or essentially these numbers go away. And so we wind up with this simplified version, 14 minus 6. Well, we already know what that is. 14 minus 6 is actually 8. And so it turns out that this point where these two things meet is 14 over 3, comma, 8. And that is actually the solution to this system of equations. By the way, if you had wanted to cheat, when you have this line, y equals 8, what we're really saying is no matter what point you pick, every single y value will equal 8. That's all that line means. So, did we have to do this? Not necessarily, but it does give us good practice for our upcoming examples. Alright, pause this video, finish working this out or writing down any notes, and let's go ahead and move on to our second example. Alright, here we have our second example, and it says solve the system of equations below, and it's essentially going to be that same question in every single one of these. But notice that we actually have not used x and y. Here, in this particular case, we're going to be using a and b. And the reason I want to switch that up is I know that students get very familiar with x, and then as soon as you see a different letter, you get a little bit tripped up. But the same principle is at play. Notice there is a equals and there is a equals. Essentially, these are still in slope-intercept form, we're just using different letters. So we can write our initial equation, this a equals 6b minus 12. And if I were to ask you, well, what is a? Well, in this top equation, a is 9b. And so we can actually rewrite this as 9b is equal to 6b minus 12. All we're doing is making a substitution for that letter A. We're saying, hey, this is what A is, but you know what? Another thing that A is 9b. Okay, now from here, this is a pretty simple equation. Let's look. We have all of our b terms or here on the left, and then we have some of our b terms here on the right, but there are also constants here on the right as well. So let me kind of back it up. Let me rephrase that. What I'm saying is this: since we have a b term and a constant here, but only b terms here, we want to move this b term to the other side. We want to get all of our b terms on one side. So how can I get rid of this positive 6b? Well, minus 6b, the opposite of positive is a negative. And remember, what we do to one side, well, we have to do to the other. So we now have 9b minus 6b, which will give us 3b, is equal to, and once that's gone, we have 3b equals negative 12. Now, if I want to get b by itself, obviously to get rid of any coefficient, we have to divide. So we'll divide both sides by 3, and b is equal to 12 divided by 3 is negative 4. Okay, now we know our b term, however, we still don't know what our a term is. And the cool thing about this is you can choose either one of these equations. It doesn't matter. So my advice to you would be to always pick the simpler equation. Let's write a equals 9b. And notice, when I write this, I can write a equals 9 parentheses because we know what b is, and b is negative 4. So, ask yourself, what is 9 times negative 4? And of course, that will be negative 36. So if I were asking you to write this in the form of a comma b, well then you could write this as negative 36 comma negative 4. Now, what if I asked you to write this in the form of b comma a? Well, in this case, we could write it as negative 4 comma negative 36. All right? Since these are not y equals mx plus b, they're not clearly an x and a y. However, I would ask you to do this. I would have to specify if I wanted it as a comma b or b comma a. If we were using it as our slope-intercept form, this would be the correct form, though. All right, let's move on to our third and final example. All right, and here we have our third and final example for level 1 slope-intercept systems. Now, notice I did use the letters P and Q. Let me go ahead and switch to a more fun color. Oh, there we go. And we're going to start solving this one the exact same way that we've solved other ones. We can go ahead and write 4Q is equal to 4Q, and that's a 4, I promise, 4Q plus 7. And why can we do that? Well, this is equal to P, and that's equal to P, so whatever P is equal to, we can set those two things equal. Now, you're going to notice something very important here, and this is going to be really important once we get to our level 5 video, is that the 4Q here and the 4Q here, they're both positive and they're both the same. So if we want to move our Q's, which are here on the right and the left, and we want to move them all to the left, ask yourself, how would you get rid of a positive 4Q? Well, you would do minus 4Q and minus 4Q. And what happens when you do 4Q minus 4Q? Well, you would get 0. In fact, you would get 0 equals 7. Now, let me ask you this. Our Q's are completely gone. We're no longer solving for Q. And is 0 equals 7, is that a true or false statement? And in this case, it is false. So, whenever your variables completely cancel out, they're completely gone, and you have a false statement, what this means is that our system has no solution. Now, what would that imply graphically? Well, I want you to see this. If these were really x's and y's, and we were to graph this as y equals 4x, our very first equation would look something like this. And if this was really 4x plus 7, 1, 2, 3, 4, 5, 6, 7, well, our second line would look like this. And notice, if you were to pretend that these were exactly straight lines, because I'm not an artist, these two lines will never cross. And if these two lines never cross, well, they have no solution. Because essentially, let me reiterate from our first example, whenever we're finding the solution to a system of equations, we're asking, where do the two lines cross? Since they don't cross, the answer is no solution. Alright, I hope these help, and good luck on these following 5 problems. I'll see you guys in our level 2 video.